Right. Let's look at 2.1.3. So the question says, initially, 10 cubic centimeter of nitrogen, 24 cubic centimeter of hydrogen are mixed in a container. All right. The temperature and the pressure remain constant. The pressure and the temperature remain constant. This does not tell us whether it's at STP or not. It's just saying the temperature, wherever it is, it remains the same. We don't know what temperature it is, but it remains the same. And for sure, it's not STP. Right? Pressure also remains constant. Right? Calculate the volume of the gas that will remain in the container after the reaction is completed. Calculate the volume of the gas that will remain in the container after the reaction is completed. Can someone explain what do you understand by this question here? What do you understand by this question? What does the question want from us? What does the question want from us? Guys, on phones, can you stop it? Nolutando, let's listen, please. You use your phones after that. Right? What do you understand here? What does the question want from us? Huh? Yeah, what does that mean? Is it comparing or just the amount of the gas? How did you understand this? Calculate the volume of gas that will remain in the container after the reaction is completed. Which gases are going to remain here? Which gases are going to remain? Don't give me names, but what are we talking about when we say the gas that remain? It means if I've got the 10 of nitrogen and the hydrogen, those two are going to react. Are we together? When they react, they're going to form another gas, which is ammonia. So that volume of ammonia and the volume that is going to remain after these two have reacted, because whatever is going to be reacting here on those two volumes that are given, they're going to form ammonia. So there will be a volume of ammonia and there will be a volume that will remain after these two have reacted, because not all of the 10 and 24 is going to react. So the total of those, the one that remain unreacted and the one that formed, what is their total when the reaction is complete? I repeat, the question wants you to tell us the volume of the gas that is going to form plus the volume of the nitrogen and the hydrogen that will remain unreacted after the reaction is complete. So your task, what is your task? Your task is to check how much of each gas is going to react and how much ammonia is going to form. Is that understood? Right, let's look at it. So for you to answer this, you're going to start from here. You start with the moles. Let's start with the moles. Nitrogen, how many moles here? 1. Hydrogen, how many? 3. Nitrogen, ammonia, how much? 2. So the ratio is 1:3:2. So 1 mole of nitrogen is going to react with 3 moles of hydrogen to give us 2 moles of ammonia. Same applies. One volume of nitrogen is going to react with how many volumes of hydrogen? 3 volumes of hydrogen to give you how many volumes of ammonia? 2 volumes of ammonia, whatever quantity you're going to be talking about. Then we are given 10 cubic centimeters. So nitrogen, initially we have got 10. We've got 10 cubic centimeters. Hydrogen, we've got how much? We've got 24. Ammonia, how much do we have when the reaction starts? Huh? We have nothing. We have 0. Because this one hasn't formed. The reaction hasn't started. So we have nothing here. Is that understood? So we are starting with 10 for nitrogen. We have got 24 for hydrogen and 0 for ammonia before the reaction starts. Are you following? Good. Now, we go further. We check. Okay, initially I've got 10, 24 and nothing here because the reaction hasn't started. Now we start the reaction. When we start the reaction, we're going to check which one am I going to use? Am I going to compare using the 10 or the 24? I'm going to use both so that I see which one is going to work out for me. So I start with 10. If I start with 10 here, how much do I need here? The ratio is 1:3. How much do I need here? I need 30. So that it reacts in the ratio 1:3. I need 30. Do you follow? Right? If I've got that 30 here, and how much am I going to form here? Yeah, I do the ratio. For me, I do 1:3. So if I've got 10, I get how much? 30. Now, here it's 1:2. If I start with 10, it means here I'm going to form how much? 20. Now, let's check this. For me to use 10 here, which is what I have here, I need 30 here. Do I have 30? No. How much do I have? 24. So it means this is not going to be possible because the 10 needs 30. But here I've got how much? 24. So I cannot use the 10. The number must be less than 10. Are you following? Right. Now, let me try the 24. The 10 is not working out because it's giving me 30, which I do not have. Are you following? Now, let's do with the 24. 24, right? If I start with 24 here, right? How much do I need here? Huh? No, the ratio is 3:1. For every 3, I need 1 here. Now I've got 24. How much do I need here? I need 8. 24 divided by 3. I need 8. Because 3:1. For every 3, I need 1. 3:1, not 1:3. 1:3, I multiply. 3:1, I divide by 3. Are you following? Right. Now, it means for 24, I need 8 of this. Are you following? Do I have the 8? Yes, because I've got 10. There's going to be a remainder even that will remain unreacted. Do you see that? So this is going to work out. Now, I come to this one now. I've got 1:2. If I start with 1, or I can do with the 24, all right? If I've got 24 here, how much am I going to form here for ammonia? My ratio is 3:2. How much am I going to form here? Huh? I'm going to get 16. How do you get 16? It's 24 divided by 3, which is 8. 8 times 2 gives me 16. Are you following? Right. Now, let's check. If I don't like the 3 and 2, I can still use 1:2. I know 8 is 1 and 2 is to what? 1:2. If I don't like the 3:2, I can just use 1:2. If 8 is 8, it means 8 will be double, which is 16. So I don't have to do the 24. Are you following? So I can compare anything here, depending the numbers that are easy to work with. I repeat, instead of using 3:2, I can use 1:2 because I know 8 is 8, so I can find the 16. Are you following? Good. Right. Now, from my options, this option is not working this. The option that is working is this. Now, I want to see what remains after the reaction, so I'm going to subtract. I started with 10 cubic centimeters. How much did I use? 8. How much is left unreacted of nitrogen? 2. 2 remains unreacted. I started with 24. I used 24. How much is left? 0. So hydrogen, all of it has been used up. All of the hydrogen reacted. So there's no hydrogen left. Then I go to the last one. In the last one, I started with nothing of ammonia. I made how much? How much? 16. So I'm going to have 16. So what is my total gas that is remaining? I've got 2 that was not used. I've got 16 that I formed. So the volume that I have at the end of the reaction is going to be 2 plus 16, which is how much? 18. My answer is 18 cubic centimeters. I pause for questions. I pause for questions. There's no formula because there's no STP. We can't use moles. We can't use VM because it's not STP. So we have to use proportion here. We have to use proportion. Yeah. Negative 60. Actually, here is supposed to be a minus because this is supposed to be a minus here. This is supposed to be a minus because I'm using this. This is supposed to be a plus. Isn't this one I'm using it? I used it, so it's no longer there. So it's 10 minus. What I'm using, I'm subtracting. Like you are baking. If I use the flour, do I still have the flour? No, I no longer have the flour. The flour has been converted into a muffin or something like that. So whatever I'm using, I'm subtracting. Whatever I'm using, I'm subtracting. Whatever I'm forming, I'm adding. So it's going to be 10 minus 8, 2. 24 minus 24, nothing. 0 plus 16, 16. 2 plus 16, 18. Yeah. 16 is the muffin that I formed, yes. So your answer is 18 cubic centimeters. So here you are being tested on proportion. You're being tested on proportion. You're being tested on proportion. So to write it nicely, maybe you could do it like this. Because I don't have space here, you could do it like this. You could do this initial. You can write this as initial. Initial. And this one is the reacted or used. This is the used. And this becomes the formed one. Formed, this is the remain, what can you say? It depends. If this one becomes the remainder, becomes the formed. So I don't know what you can write. You can just find a term to write this. But these are the initial values that I have. This is what I've used and formed as well. All right. Then this is the balance. This is the balance. They call it the balance. Or the remaining ones. The balance. So this row represents the balance. By balance, we mean the one that was used and the one that was formed. So I'm going to add what remained in the container. So it's 2 plus 16 to give me 18. Clear? Right. Okay. So that's how you do that. Yes. Centimeter key. Yeah. It's a centimeter. It's centimeter because we have centimeter. You wanted it to be cubic decimeter? No, because we have centimeter cubed. Because we're just doing a ratio. There's no formula that is gonna maybe conflict the units. I'm just using ratio. So my ratios will still be, so it's cubic centimeter. You don't have to convert. We only convert because on our formula, we've got V over Vm. So if I don't convert, here I'm gonna have cubic centimeters. Here I'm going to have cubic centimeter. At the bottom, I'm going to have cubic decimeter. So these two cannot cancel because my answer must come up with moles. And here, molar volume, I know it's cubic decimeter per mole. Here, there's a per mole here. There's per mole. Right? So I need these two to cancel so that my answer remains moles. So if these two, they don't cancel, then it means my answer is going to be wrong, because it's going to be cubic per decimeter mole, which is not the units of moles. So that's why these two must cancel. So for them to cancel, I have to convert the cubic centimeter to cubic decimeter so that they can cancel. Then my units become moles, because n represents number of moles. But here we're just doing proportion and the units are the same. So I might as well work with cubic centimeters. It's fine. Okay. All right, we move on to the next one. We move on to the next one. In another experiment, I'll erase this. Right. In another experiment, 80 grams of hydrogen gas reacts with nitrogen gas to form ammonia. All right, calculate the number of moles of hydrogen gas that reacted. All right, 2.1.4, we are looking for number of moles. Number of moles. In number of moles, what are we given here? We are given 80 grams. And we're looking for number of moles. So what formula are we going to use? Number of moles is equal to mass over molar mass. Right? Then what we have got to 80 divided by the molar mass of hydrogen. What is the molar mass for hydrogen gas? There's gas there. So you're not going to use 1, because gas, hydrogen is always a diatomic molecule. Diatomic makes it how much? 2. So 80 divided by 2 gives you 40. So the answer is 40 moles. 40 moles. Right? Okay. How many marks is it? 2. Right? 2 marks. You've got mark for substitution, mark for the answer. So you've got 2 marks. No mark for formula. This is 2.14. 2.14. Yes. The molar mass, I go in the periodic table and check. Hydrogen is 1. But this is hydrogen gas. Hydrogen gas means H2. Hydrogen becomes, so 1 times 2 gives us 2. All right, then we move on to the next one, 2.15. The volume of nitrogen gas used at STP. Volume of nitrogen gas used at STP. Once again, I'm looking for volume. And STP, it means I've got molar volume. Are we following? All right, so I need number of moles for me to be able to use the formula. Number of moles is equal to V over Vm. Are you following? All right, first I need to get the number of moles. How do I do that? I go to my formula and check. I must compare what I have versus what I do not have. So I'm going to compare. Hydrogen is what I have. Hydrogen is to nitrogen. All right, I go to my balance equation and check. Hydrogen is to nitrogen. What is the ratio? 3:1. Am I right? No. Hydrogen is how much? 3. I have hydrogen. I'm looking for nitrogen. So it's 3:1. I don't have nitrogen. So I start with the one that I have. 3 is to what I don't have, which is nitrogen. Right. Then after that, your ratio is going to be 3:1. And here, how much do I have here? Hydrogen, how many moles do I have? I've got 40. So if I've got 40, how much must I have this side to correspond to the ratio 3:1? 120? No. I expect to get a smaller number than 40 because 3:1. 1 must be less. 13 comma. So it's going to be, I'm going to divide 40 divided by 3. So I'm going to get 13,33. It recurs. So number of moles of nitrogen is 13,333. After I get my moles, now I go to my equation here. Where there's number of moles, I put 13,33. Is equal to the volume over molar volume, STP. STP, I'm going to put 22,4. Then my volume, what is my volume? It becomes 13,33 multiplied by 22,4. What's your answer? 298,67. Right, 67. And what are the units? Cubic decimeters. That becomes our answer. Right, for 2 marks again. What are the 2 marks for? It's going to be your substitution here and your answer here. Substitution and your answer. But it was supposed to be at least 3, at least for that ratio. I don't know why it's 2. It's supposed to be that and that. Let me get that. Hello. What is it? I thought it was a cockroach. All right, okay. All right. So your answer is 298,67. That's what you get. All right, please give a total out of 25 for question number 1 and number 2. Give a total out of 25 for question number 1 and number 2. The total there is 25. All right. People online, any questions? Guys, stop making noise, please. Just step on that beam. Huh? If it's on the floor. Okay, or close that window, Zama. Right. Okay. Anyone with questions on this? What is this? This activity here? No questions. Right. I'm not gonna proceed to do percentage yield. Instead, what I'm gonna do, I've got another handout that I have here. I've just prepared one question with a graph that I would like you to do, like today's homework. Just one question out of 30 marks. All right, so it's gonna be this here. I'll post it now. This is the one here. All right, I would like you to do this. All right. Right, so it's exercise 36. I'm gonna post that. You guys, you attempt this one as well. All right, it's asking about concentration, define concentration, and you do some calculations using the graph here. Right, if there are no questions, then let's meet tomorrow. Tomorrow we'll look at a percentage yield. Yes? This one? Yes, all of it. It's out of 13 marks, just one. Huh? Yeah, 1.33. Just out of 13 marks. So that's your homework today. Come again? Right. So that's your homework. I'm gonna post it now. Please do that. Let's meet tomorrow. Let's meet tomorrow. Enjoy the rest of your day. Be safe. Okay. Why?